this equation here, bit of a jumble, products, quotients, functions of functions, all sorts. Now all it wants isn't the derivative, it's just the gradient, the value of the gradient. Obviously you have to differentiate it, but that just means you don't need to tidy it up. Differentiate it and then put zeros in for the x's, and then you'll find the final value. But this looks like an obvious candidate for logarithmic, just to split these apart. So take the logarithm of both sides. So it's 3 parts here. This product will be the sum of 2 logs, that quotient will be a subtractor log. Any power will go to the front of the log. So that part's going to become sine x ln e, if you like, plus 3 ln 2 plus x, and that's a minus, and it's power a half of ln 1 minus x. Then differentiating. So you've got ln goes to 1 over the thing times the derivative of the thing. Ln of e, what power of e gives e? That's just 1. So sine, that just goes to cos. That becomes 3 over the thing. So 3 over 2 plus x, the derivative of that's just 1, so it doesn't matter. Minus a half over 1 minus x. So that's a 1 over 2 times 1 minus x. Derivative of that's a negative, so multiplying by that negative makes that a plus. So I've almost got it. So dy by dx is just going to be this thing, cos x, 3 over 2 plus x. I'm not going to bother adding these up because all these x's are about to be replaced by zeros, and I know I could work out y by putting x's there. I'll just bump this back in. E to the sine x, doesn't take that long just to write out, to the power 3 over root 1 minus x. And then when x equals 0, that means that the gradient equal to the derivative of that point will equal, just fill these things full of zeros. So that's going to be, I'll just work it out as it goes. So it's going to be cos of 0, 1, plus 2 and 0 is 2, so 3 upon 2, plus 1 minus 0 is 1, so that's plus a half, times e to the sine 0. Sine 0 is 0, so it's e to the 0, so it's 1. Am I showing too little working? I don't know. Times x is 0, so it's 2 to the 3, so that's 8. 1 minus 0 is 1, square root's 1. So what I've got is, here I've got 2, 1 is 3, that just comes to 8, which means that m is equal to 24. And that would be the final answer. Now, question 8. First part, write an expression for this. Oh, fair enough, it's just 1 mark, so you could just write it down. Now, you need to know the ones for sigma r, r squared and r cubed. But these two are particularly easy to remember, you just need to remember one of them, because that is just the square of that, so the answer is 0. I'll put this one down first. That expression is a half n plus 1, and r cubed is the same as that, only squared. A quarter n squared n plus 1 squared, which means the difference between them must be 0. Don't really need to spell it out, I'll spell it out, it only says state. N plus 1 squared minus a quarter n squared n plus 1 squared, so that equals 0. Oh, now, this is where it comes in. And an expression for this. Now, there's only 1 mark for the first part. And the second part is exactly the same, the only difference being it's got a sum instead of a difference. So there's obviously some misprint happened here. That could possibly be worth 3 marks after you've just carried the subtraction. Because obviously if the subtraction is 0, then the sum's just going to be double one of them. It's going to be a half n. It's just going to be that one doubled. That can't be 3. There's obviously a misprint. It may well be the misprint was in the first bit. And maybe it was just a case of write down an expression for this, or write down an expression for that, and then this part was worth the 3 marks. But I only assume there was some mistake, because this is just ridiculous. Once you've done that, the answer to that is just going to be double that. You've already done it. You've got a quarter of n squared, n plus 1 squared, plus a quarter of n squared, n plus 1 squared, so it's a half of n squared, n plus 1 squared. Well, that was question 8. Number 9, a little differential equation, first order differential equation. The x's and y's are quite separate, so that's a separable one. although you could split those into two factors and have a y multiplied by that to take over, and then leaving that root x on that side and do it as one requiring an integrating factor, but that'd be daft. It separates quite easily. dy over 1 plus y is 3 times, I'll put that into index form for the purposes of carrying the integration, so the integral of that is, just sneak that in there because that's just a constant. So that's just going to become ln of 1 plus y, and that's going to become 3 times up to 3 upon 2, divide by that, so multiply by 2 upon 3 plus c. So that means I've got, I'll take that up in the next line, I've got 1 plus y equals e to that power, so that comes down to 2 times 1 plus x to the power 3 upon 2 plus c. Well, that plus c could come to the front. You can consider that as e to the a plus b, which of course would be e to the a times e to the b. So you could make that a e to the 2 1 plus x to the 3 upon 2. I'll just put a wee note where a would equal that e to the power c part. I'll have to use another line now. So finally, y is going to equal a e to the 2 times 1 plus x to the 3 upon 2 minus 1. Number 10. Identify the locus, or the allowed positions, of this expression here, which means, whoops, the distance between the number z and the number 1 is always going to be 3. Well, that's just going to form a circle then of radius 3 about the number 1. That's it identified. Well, I suppose we'll have to do more than that. Well, let's just say this then. Let z be x plus iy. Then z minus 1 will be x minus 1, being the real part, because it's just 1 away, plus iy. So that expression then is the same as x minus 1 plus iy has to equal 3. Right, well, that means that the square of it then will equal 9. X minus 1 plus iy. So that's, for the length of that then, x plus 1 and y, that's the same as x squared plus y squared equals 9. And that's immediately recognisable, just as it said before, as a circle centred on 1 with radius 3 squared, radius 3, which equals a circle centre 1 0 radius 3 for the first part, which is just what it says anyway. The distance between any point z and 1 is always 3, so it's going to form a circle. Identify, well I draw it, so it's just going to fit in that. This is just guesswork here for this part. Is that going to be the centre? Yeah, good enough. Of radius 3. Well, if that's, suppose you can see, if that's radius 3, then that's going to be, well, it's not very good there, is it? Negative 2, and that's going to be 4. Next bit. Show a diagram, what's half drawn already. The region given by z minus 1 is less than or equal to 3. Well, equals 3 on the circumference, less than inside it. So it's the interior of the circle centred at 1. And that would be the answer to that question. Number 11. Obtain the exact value. Well, what else would you do? Not going to use a calculator, are we? No, we are purists. So, well, first of all, the first thing you notice there is, okay, you've got a product, but it's a difference of 2 squares. So that's just going to be from 0 to pi upon 4 of sec squared, which you recognise immediately, minus x squared, which is trivial anyway. So that's going to be sec squared goes back to tan, and that's going to go back to 1/3 of x cubed. Evaluate at 0, evaluate at pi upon 4. Spell that out if you will. So that's going to be tan pi upon 4 minus 1/3 of pi upon 4 cubed, big denominator, minus, tan 0 minus 1/3 of 0 cubed, that whole part is going to be 0. Well, you know that one anyway. The tan of 45, that's 1. So that's 1 minus, and that's going to be 64, so it's 1/3 of 64. 64 1812, 192, 1 over 192 pi cubed minus 0. Will that do? Will it break? 1 minus pi cubed over 192. No, I prefer the way it was. Right, that's part A. 11 part B. Right, for 4 marks, find the integral of this. Looks very much like inverse sine, 1 over the square root of 1 minus something squared. In fact, this could be done just by inspection that way, because that's the square of 7x squared, and the derivative of 7x squared is 14x. The top is a multiple of the derivative of that. It's a 14th of it, so straight away the answer to that is going to be 1/14 inverse sine 7x squared plus c. But I expect they want you to show some working, so we'll just have to set it all out some sort of substitution way then. So why not do that then? You suspect it's going to be the form of 1 minus something squared, so let u, or some other variable, equal the thing which is being squared, which is 7x squared. So you've got du by dx is going to be 14x, so that the dx can be replaced by du over 14x. So that would change into, there's the x, this is going to be 1 minus, and that's going to be the u squared now. That's going to be du over 14x. Take the 14th out as a factor. The x is cancelled and we're left with du over the square root of 1 minus u squared, which is 1/14 of, that's now simply inverse sine of u plus c, replacing it 1/14 of inverse sine of, as suspected all along, dear me, home alone, but all along though, 1/14 inverse sine of 7x squared plus c. Number 12, prove by induction, 5 marks, this proposition. The proposition is that 8 to the power n plus 3 to n minus 2 divides by 5 for all integral values of n greater than or equal to 2. So the lowest value considering is 2. Well, let's just see if that's right. Try it for n equals 2. If n equals 2, what have you got? You've got 8 squared plus 3 to the power 0, which equals 64 plus 1, which is 65, which divides by 5. I'll just write that in words. Which divides by 5. So the first part is, it's certainly true for n equals 2. Next part. Well, let's just assume it's true at some arbitrary point further on. Let's assume it's true for n equals some other number, k, some other integral value of n greater than 2, k. That would mean that, I'll put it down here, that would mean that 8 to the k plus 3 to the k minus 2 divides by 5, which I'll have to express algebraically in some form, rather than just having words. We can't just manipulate the words. That's for the politicians. So that would be, if it divides by 5, it must be 5 times something. Call it m, where m would be some number, or just a natural number would do for it because it's only positives we're considering anyway. And we'll call that 1. That's the inductive hypothesis. Right, now consider n equals k plus 1. In other words, consider the number just after that. So we're saying it's true here. What about the one just after it? I want to establish that link. If it's true for this, is it true for the next one? Because that would be significant. Well, considering that means I'd have this expression. 8 to the k plus 1 plus 3 to the k plus 1 minus 2. I'll just write that again. 8 to the k plus 1 plus 3 to the k plus 1 minus 2, k minus 1. Now at some point you have to call in, that's why I've given it a name, this inductive hypothesis. Well, an obvious thing you usually do is take out a factor. So 8 times 8 to the k is handy because it's recreated that part. And if I take a 3 out of that, so this power drops by 1, I'll have 3 to the k minus 2, which has created that part, but they're a bit messed up here. Somehow I want to have this expression. If only that had said 8 to the k plus 8, 3 to the k minus 2, then I would have 8 of them. But you can do that. You can create terms as long as you amend them. So that's what I'll do. I'll say we'll make that 8 times 8 to the k plus 8 times 3 to the k minus 2, because that means I could just use this, substitute that in. Only I didn't have 8, only had 3, so correct it by taking away 5. Ah, look, there's that magic number appearing, k minus 2. So going back up to the top, take out that common factor then, so I've got 8 times 8 to the k plus 3 to the k minus 2 minus 5 times 3 to the k minus 2, which is fine already because that's a multiple of 5. But then, so was this. That was equal to, by 1, which I just rubbed off there, 5m minus 5 times 3 to the k minus 2. That was by 1, which I just rubbed off, which gives me 5 times 8m minus 3 to the k minus 2, which is a multiple of 5, which means it divides by 5. Multiple of 5, which meant the original expression divided by 5. 8 to the k plus 1 plus 3 to the k minus 1 divides by 5. And then you just finish it off. So it was true then. So what that said was, what that meant was, if it was true for n equals k, then it was true for the next one, n equals k plus 1. But since it was true at n equals 2, that means it's going to be true forever after. True for 2, true for 3, true for 3, true for 4, and so on. It's going to be true for all n, where n was greater or equal to 2, and n was integers or natural numbers, whichever you will, since they're positive anyway. Right, that was that one. Question 13. Arithmetic sequence. The first 3 terms of an arithmetic sequence are these: a, 1 over a, and 1. Obtain the value of a and the common difference. Well, a is just the first term. The common difference, well, in an arithmetic series, you start with a certain value, and then you keep adding the difference, and so on, which means you can get the difference by subtracting any 2 consecutive terms. So I can get the difference by subtracting these 2 terms, u2 minus u1, and that should be the same as doing u3 minus u2. So what have I got if I do that? So that would mean that 1 over a minus a is going to be the same as 1 minus 1 over a. Multiply everything by a. So that means I'll have 1 minus a squared is a minus 1. There's a quadratic. Take it over to this side, but write it this way. So I've got a squared plus a minus 2 equals 0. Factorise it. A, 1, 2, plus to the bigger, opposite signs. So a equals 1 or a equals negative 2. But I said a was less than 0. I put the negative in, which meant that a equals negative 2 because a was less than 0. So that's a found. Get d just by putting it back in again, which means that d is going to be, well, u2 was 1 over negative 2, take away negative 2, so that I've got 2 take away a half, which is 1 and a half, which is 3 upon 2. So d equals 3 upon 2 for the first bit. Second part, obtain the smallest value of n for which the sum of the first n terms is greater than 1,000. Well, the formula, which you all need to remember, is a half n times 2a plus n minus 1d, which is like saying the average of the first plus the last. A being the first and a plus n minus 1d being the last. And that answer, it says, has to be greater than 1,000. Oh, just a case of feeding that lot in then. That means a half n, which I don't know, is 2 times, but a I do know, plus n minus 1 times d, which I do know, has to be greater than 1,000. Well, there's an equation. Or rather, there's an inequation which needs to be solved. Well, I'll just multiply it out first of all. So that means I've got negative 2n plus, then multiplying these parts together, I've got 3/4 of n squared minus 3/4 of just n has to be greater than 1,000. Now there's a quadratic inequation coming on. For a quadratic inequation, the way you solve that, yes, you can factorise, is by considering the graph of it. When are the answers above, when are they below? But I'll need to type that up first. First thing I'll do is get rid of these 4's. So multiplying everything by 4. Negative 8n plus 3n squared minus 3n is greater than 4,000. Then taking it all over to one side, I've got 3n squared minus 11n minus the 4,000 is greater than 0. Now considering the graph of that would look like this. Positive. There's going to be two values. It's going to be exceeding the upper root or below the lower root. And then 11 squared take away, which is plus that lot. I don't trust that that's going to factorise nicely, especially if it says find the least value. So we'll just find the value by using the roots then, the quadratic formula. But I know that, since it's a quadratic, that n will have to be greater than the upper root of the equation equal to 0, or lower than the lower root, but it's only the upper one we're considering. So I'm just going to n greater than, and then just put in the quadratic formula. So that'll be 11 plus, because it's upper root, that'll be 121 minus 12 times that, that's 48,000, but it's plus, because it's take away a negative, over 6. And it was just a case of pressing the buttons for that. Right, so I came back in there, has to be greater than that, which means that the least value, the smallest value of n is 39. Yeah, that's that one.